Hello everyone, and welcome to our 20-slide comprehensive guide on data mastery. Today, we'll explore essential skills like import data, Power Query, data cleaning, and transformation. We'll cover how to efficiently import, clean, and transform data to make analysis-ready datasets. So, let's dive in and get started on mastering your data skills. Let's take a look at slide 2, where we'll outline the key points we'll cover in this course. First, we'll discuss data import methods, including how to bring in data from Excel, CSV files, SQL databases, and APIs. This is essential because understanding where your data comes from is the foundation of any data transformation process. Next, we'll dive into ETL basics and the Power Query interface, which is a powerful tool for cleaning and transforming your data efficiently. We'll explore different types of transformations, such as calculations and output, which help us shape the data to meet our needs. Then, we'll talk about combining tables through merging and appending, which allows us to consolidate data from various sources. After that, we'll focus on identifying and eliminating issues like duplicates, nulls, errors, and formatting inconsistencies, crucial steps to ensure data quality. Throughout this course, you'll see how all these pieces fit together in a comprehensive data pipeline, from importing raw data to cleaning and transforming it for analysis. This roadmap will guide us through the entire process, equipping you with practical skills to handle real-world data challenges. Let's talk about why data quality really matters. When data in CRMs is inaccurate or outdated within just a year, it can lead to misleading insights. And those insights are crucial because they drive our decisions. If the data isn't reliable, our decisions may not be as effective, which puts us at a disadvantage compared to competitors. Now, on average, poor data quality costs organizations around $15 million each year. That's a significant amount of money lost simply because the data isn't up to par. And here's another eye-opener. About 80% of an analyst's time is spent cleaning and fixing data rather than analyzing it. This means we're not using our talent and resources efficiently. All of these points highlight a key idea. Bad data isn't just a minor issue. It has real, tangible costs that impact our bottom line and our ability to compete effectively. Now let's walk through how to import data using Power Query. Starting with data from text or CSV files, you go to Power Query, then Data and select Get Data. From there, choose from File and then from Text CSV. When you're working with these files, it's important to check a few key settings. First, the delimiter, whether it's a comma, tab, semicolon, or a custom character. This determines how your data is split into columns. Next, set the encoding to UTF-8 to avoid any character errors, especially if your data includes special characters. Also, ensure that the first row is toggled on as headers, so your column names are correctly recognized. Power Query detects data types based on the first 200 rows, but always double-check, especially for dates, because formats like DD versus DDMM can cause issues. Switching to CSV files, which are comma-separated values, the process is similar. You select your CSV file, and the navigator pane opens, allowing you to choose the specific sheet or table you want to import. Before loading, always preview your data to ensure everything looks correct. If needed, click Transform Data to make edits within Power Query. Once satisfied, you click Close and load to bring the data into Excel or your data model. Now, importing from Excel files follows a similar process. You select your XLSX or XLS file, and again, the navigator pane appears. You pick the sheet or table you need, preview the data, and then decide whether to load it directly or transform it first. When transforming, you can clean or shape your data as needed before loading it into your workbook. Remember, these steps are fundamental for ensuring your data is accurate and ready for analysis. Properly importing data sets the foundation for everything that follows in your project. Let's talk about a really useful tip when working with Power BI and databases. Using Direct Query mode allows you to keep your SQL connection live, which means there's no need to copy all the data into Power BI. This is especially beneficial when dealing with large datasets, as it helps maintain performance. Power Query plays a key role here because it pushes filters and query logic back to your SQL database. This process is known as query folding. The result is a huge performance boost, since only the filtered data is transferred, rather than the entire dataset. Now, when connecting to a database, you'll typically start by picking a table from the navigator or writing a custom SQL query if you need something specific. This gives you flexibility in choosing the data you want to work with. Next, you'll select the table or query you've prepared. Then, you'll need to authenticate your connection. You can choose from options like Windows authentication, database credentials, or signing in with your Microsoft account, especially if you're connecting to Azure. After authentication, you'll enter your server details. This includes the server name or IP address, the database name, and the port number. Default for SQL Server is 1433. Providing accurate details here is essential for a successful connection. Once you've entered the server info, you'll go to the Open Connection step. From there, you'll navigate through Power Query by selecting Get Data, then from Database, and choosing your specific database type, whether it's SQL Server, MySQL, PostgreSQL, or Oracle. And remember, Power Query supports a variety of databases, making it a versatile tool for connecting to different data sources seamlessly. So, combining these steps with the ability to use direct query mode really empowers you to build efficient and scalable reports, making your data work smarter, not harder. All right, let's walk through this Power Query M code step by step. First, we start by defining the URL, which in this case is a sample API endpoint, https://API, site, com/records. This is where we're pulling our data from. Next, we set up our headers. These include the authorization header with a bearer token. This is essential for authenticating our request, and the content type, which we set to application/JSON because we're working with JSON data. Then we use web contents to make the actual web request, passing in the URL and headers. This function retrieves the raw response from the API. After getting the response, we parse it into a JSON document using JSON document. This step converts the raw response into a readable format. Finally, we transform this JSON into a table using table from list, which makes it easier to work within Power BI. The splitter, split by nothing, function indicates that each item in the list becomes a row in the table. And that's the core flow, connecting to an API, authenticating, retrieving data, parsing JSON, and converting it into a table for analysis. This process is fundamental when importing data from REST APIs into Power BI, especially when dealing with dynamic or paginated data sources. Now, moving on to the Power Query interface, this slide highlights some of the key components and actions you'll encounter. At the top, you'll see the ribbon with options like Home, Transform, Add Column, and View. These are your main tools for shaping and analyzing your data. Under the Applied Steps section, you can see the sequence of actions we've taken, like removed nulls, changed type, and promoted headers. Each step builds on the previous one, helping us clean and prepare the data for analysis. On the right, there's the navigation pane, which allows us to see the data source, and the data preview area, where you can see a snapshot of your data before it's loaded into Excel. Below that, the Queries panel lists all the queries in your workbook, giving you an overview of your data transformations. Remember, every action you take here is recorded step by step, which makes it easy to review or modify your data preparation process later. Understanding these components helps you efficiently navigate and utilize Power Query in your data workflows. Now, let's look at the different ways we can work with data once it's been prepared. First, we can output our data to an Excel table, which is great for further analysis or sharing. Then, we have the option to load that data into a data model, which helps us create more complex reports and relationships. From there, we can publish our reports directly to Power BI, making them accessible across our organization. To keep our data current, scheduling refreshes is essential, so our reports always reflect the latest information. The load step is where all the transformed data finally gets into its destination for analysis. On the transformation side, we start by connecting to our data sources, whether it's Excel files, CSVs, SQL databases, APIs, web pages, or SharePoint. We can even handle multiple files at once, which saves us time. Once connected, we extract the data, and this is where the real work begins. We clean and shape our data by removing nulls and duplicates, merging or appending tables, and calculating new columns to enhance our dataset. This entire process, extract, transform, and load, is what we call ETL, and it's fundamental for preparing data for analysis. Power Query, which we're focusing on in this module, makes all these steps accessible and manageable, empowering us to turn raw data into valuable insights efficiently. Now let's talk about handling null values and blanks in your data. First and foremost, never delete nulls blindly. Before removing or replacing them, it's crucial to understand why the data is missing. Is it missing at random, or is there a not at random reason? That understanding guides your approach. One way to deal with missing data is by adding a custom column, for example using table. Average on your source data to fill in gaps for numeric fields. This is called statistical imputation, and replacing missing values with the mean or median is a common practice. Another simple method is selecting the column, then going to transform, and using fill down, which copies the value from the cell above into the blank below. This works well when your data has merged cells exported as nulls. If you prefer, you can also use fill up, which does the opposite, fills blanks by copying values from below. And for cases where nulls represent a default or unknown state, you can replace nulls by transforming, then choosing replace values, entering null, and replacing with 0, unknown, or NA. Sometimes null rows are simply invalid data, and in those cases, you might want to remove the entire row. You can do that via Home, remove rows, remove blank rows, or by filtering out null or blank entries directly. The key takeaway is that handling nulls thoughtfully ensures your data stays clean and reliable, which is essential for accurate analysis and insights. Now let's look at some common data cleaning steps that are essential for preparing your data. First, we often encounter normalized text, which includes characters like n tilde, e acute, and u umlaut. These special characters can sometimes cause issues, so we need to handle them carefully. Next, we deal with special characters, which might be unnecessary or problematic in our dataset. Removing errors or replacing erroneous data is crucial. Sometimes we encounter null values or placeholders like error or NA, which need to be addressed to ensure data accuracy. When working with dates, we transform text into a date format by parsing different date representations, like 10522024 or 1052024, into a consistent date format. This step is vital for accurate date analysis. Changing data types is another key step. For example, converting numbers stored as text, such as 123, into a proper whole number ensures calculations and aggregations work correctly. We also improve readability and consistency by capitalizing each word, turning Alice or Alice into Alice. This standardization makes data easier to interpret. Finally, trimming extra spaces is often overlooked, but just as important. Removing leading or trailing spaces from entries like Alice helps prevent mismatches and errors in your data. All these transformations, fixing errors, standardizing formats, and cleaning up inconsistencies, are essential to ensure your data is accurate and reliable for analysis. This is what we focus on in the Clean Data module. Now let's take a closer look at some essential text cleaning functions in Power Query. First, we have text, length, which simply counts the number of characters in a string. For example, the word hello has a length of 5. This helps us understand the size of our data entries. Next, we have text, start, which extracts the first few characters from a string. So if we want the first 3 characters of hello, we get hell. Similarly, text. End allows us to pull the last few characters, which can be useful for specific data manipulations. Another important function is text split. Imagine splitting a string like A, B, C by the comma delimiter. This creates a list of separate items. A, B, and C. This is particularly helpful when dealing with delimited data. Moving on, text. Replace enables us to find and swap out substrings within our text. For example, changing John Doe to John Doe by capitalizing the first letters. That brings us to text proper, which converts each word in a string to title case, making data more readable. Then we have text upper and text lower, which change all characters to uppercase or lowercase, respectively, useful for standardizing data formats. Sometimes our text contains non-printable characters or extra spaces, and that's where text clean and text trim come in. Text clean removes any non-printable characters, and text trim eliminates leading and trailing whitespace, ensuring our data is clean and consistent. All these functions are part of what we call text cleaning in Power Query, a crucial step in preparing our data for analysis. Properly cleaning data ensures accuracy and reliability in our results. Now let's look at how to remove duplicates in Power Query. For the entire dataset, you can go to the Home tab, then choose Remove Rows and select Remove Duplicates. If you want to target specific columns, you can select those columns first, right-click, and then choose Remove Duplicates. There's also an option to keep only duplicates, which is especially useful for auditing purposes. To do that, go to Home, then Keep Rows and select Keep Duplicates. This helps you identify which data entries are repeated. Looking at this example, before removing duplicates, we see the raw data with some repeated rows. After applying the Remove Duplicates step, duplicates like the $310, Alice, 1003 entries are eliminated, leaving only unique records. It's important to understand these options because they give you control over how you clean and prepare your data. Removing duplicates helps ensure your analysis is accurate, while keeping duplicates can help you spot issues or patterns. So, in summary, Power Query provides flexible ways to identify and remove duplicates, whether across the entire dataset or within specific columns, and even to keep only the duplicates for analysis. This step is essential for maintaining data integrity as part of your overall data cleaning process. Let's start by using the Keep Duplicates option first to review what will be removed. It's important to check whether these duplicates have different values in other columns. If they do, then they might not actually be true duplicates, but rather data quality issues. Remember, Power Query always keeps the first occurrence of any duplicate. If you prefer to keep the last one instead, you can sort your table in descending order by date or version before removing duplicates, and then resort ascending afterward. Sometimes, duplicates aren't obvious when looking at just one column. They may only be duplicates when multiple columns are considered together. For example, combining customer ID, order date, and product ID might reveal true duplicates that wouldn't be caught by looking at each column separately. In that case, you select all those key columns and remove duplicates based on that composite key. Now, standard remove duplicates typically uses an exact match, which works well for identical data. But what if you have slight variations, like Alice Smith versus A. Smith? For fuzzy duplicates, you'll need different tools. In Power BI, you can use Table, Fuzzy Join with a threshold. In Python, the Rapid Fuzz library is quite handy. And in Excel, there's the Power Query Fuzzy Merge Preview feature. These fuzzy matching techniques allow you to identify potential duplicates, even when the data isn't exactly the same, making your deduplication more robust. And that wraps up our overview of advanced deduplication strategies. Remember, choosing the right approach depends on your data quality and the level of accuracy you need. Now, let's look at the different types of joins we can use when merging tables. Starting with the right excluding, also known as right anti, this includes rows in the right table that have no match in the left. It's useful when you want to identify data that exists only on one side. Similarly, the left excluding, or left anti, finds rows in the left table with no match in the right, helping us find missing data. Moving on, the inner join is perhaps the most common. It returns only the rows that match in both tables, giving us a focused view of shared data. Then, we have the full outer join, which includes all rows from both tables, matching where possible, and filling in gaps with nulls where there's no match. The right outer join brings in all rows from the right table, plus the matching rows from the left, while the left outer join does the same but starting from the left table. The most frequently used in practice is the left join, as it's straightforward and covers most scenarios where we want to see all data from the main table along with related details from another. Finally, in our overall process, we often start with a merge queries operation, combining two tables based on a key column. Understanding these different join types helps us control exactly what data we want to include in our analysis. Now let's walk through the steps for combining tables. First, go to the Home tab, then click on Append Queries. You'll see options to select either 2 tables or 3 or more tables. Choose the appropriate option based on how many tables you want to combine. Next, select the tables you want to append, and then click OK. A key point to remember is that columns are matched by name. If there are mismatched columns, those will become null, so always double-check that the column names match exactly across your tables. Another powerful feature is combining files from a folder. To do this, go to Data, then Get Data, then from File, and choose from Folder. This automatically appends all files within that folder, super handy for consolidating multiple datasets quickly. For example, you might have a table with all sales data, then a table with just February sales, and another with January sales. When you append these, it stacks one table on top of the other, similar to a SQL union all operation. Remember, appending is essentially stacking rows from different tables into one combined table, which helps you analyze data across different periods or categories seamlessly. This process is part of merge and append techniques in Module 5, and mastering it is crucial for efficient data consolidation. Let's talk about what to avoid when working with data types in Power Query, because it can really slow down your processing if not handled properly. For example, mixing different types within the same column can cause significant delays. Imagine a column that contains both numbers and text. Power Query has to constantly switch contexts, which slows everything down. Similarly, flags or yes/no fields like true or false are straightforward, but if you have inconsistent entries, say some trues and some yes or no, that can create confusion and processing issues. Names, codes, and descriptions, like hello or ID 001, are usually text, but mixing them with other data types can be problematic. Keep these distinct to maintain efficiency. Timestamps and logs, such as 115-2024-14-30, are date-time data types, and handling them correctly is key. If you try to treat them as plain text, it can slow things down and create errors. Similarly, calendar dates without specific times, like 115-2024, should be kept as date data types. Combining those with other types can hinder performance. Financial data, like $1,200.50, should be treated as currency data, with a fixed number of decimal places, usually 4. Mixing currency with other numerical types can cause slowdowns. Prices, rates, and measurements like 3.14 or minus 0.5 are decimal numbers. Keeping these separate from whole numbers or text helps Power Query process data more efficiently. Finally, IDs, counts, and quantities, like 42, minus 10, or 1,000, are best kept as whole number data types. Mixing them with other types again can slow down your workflow. Overall, the key takeaway is to carefully assign and maintain consistent data types to avoid unnecessary processing delays, and keep your Power Query transformations running smoothly. Now let's look at some key points about transformations in Power Query. First, all transformations are non-destructive, which means every step is recorded in the Applied Steps pane. This makes it easy to undo or modify any step if needed. We can split a column by a delimiter or by position, allowing us to break apart data into more manageable parts. Similarly, merging columns is straightforward. Just concatenate them with a separator to create a combined field. Reshaping data is also simple with pivot and unpivot functions, which let us switch between wide and long formats. Transposing flips rows and columns, giving us a different perspective on the data. Adding an index column automatically assigns row numbers, which can be useful for tracking or sorting. When working with dates, we can extract components like year, month, day, or quarter, and also determine the day of the week or week number. Calculating age is easy. Subtract the date from the current date to find the number of days since. We can also find the difference in days between two dates with date, diff days. Combining date and time into a single date-time value is another common task. Date transformations include rounding dates up or down, and taking the absolute value to remove negatives. To express numbers as percentages, we divide by 100, or use a custom calculation like dividing by 1,000 for thousands. For cumulative calculations, we can create a running total using the index and group by functions. Number transformations also include key column transformations, which help us modify data types and prepare data for analysis. All of these tools are part of the Data Types and Transformations module, and mastering them helps us transform raw data into insightful, structured information. Now let's look at the result of creating a new tier column, which categorizes our data into premium, standard, or basic based on the amount value. If the amount exceeds 1,000, it labels it as premium. If it's greater than 500 but less than or equal to 1,000, it becomes standard. Otherwise, it defaults to basic. Next, we have an else condition that outputs basic for amounts that don't meet the higher thresholds, ensuring every record gets a category. Similarly, for standard, we set a threshold of 500, so amounts between 501 and 1,000 are labeled accordingly. Moving on, we see how to add a new column using Power Query's conditional column feature, which doesn't require coding. For example, we extract the year from a date and format it with a dash before the month, padding the month with a 0 if needed. This creates a year-month column in a consistent format. We also categorize data based on the amount again, labeling entries as high if over 1,000 or low otherwise. This helps in segmenting our data for better analysis. Another quick example is creating a full name column by concatenating the first and last names with a space in between. This simplifies referencing full names in our reports. Finally, we look at the profit margin calculation, which involves adding a custom column using M language. This is part of our broader focus on data types and transformations, essential skills for shaping our data effectively. All these steps demonstrate how to enhance our data with calculated columns, making our analysis more insightful and tailored to our needs. Now, as we reach the final step in our end-to-end data preparation workflow, it's important to see how all these pieces come together. This last slide is about putting everything into action, integrating each step to ensure a smooth and efficient data pipeline. From connecting to your data source, whether it's Excel, CSV, SQL, or an API, to inspecting and cleaning your data, each stage plays a vital role. Then, adding columns, merging datasets, and performing calculations help shape your data for analysis. Handling nulls and fixing data types ensure accuracy, while quality checks like column distribution and error detection keep your data reliable. Finally, scheduling auto-refresh and loading everything into your model allows for ongoing updates and seamless integration. Remember, the key is to see this as a continuous cycle. Each step feeds into the next, creating a robust and dynamic data workflow that supports your overall analytics goals. All right, let's talk about what makes data truly ready for analysis. First off, clean data is the foundation of every great dashboard, report, and business decision. Without it, your insights won't be reliable or actionable. One way to ensure flexibility is by using parameters for file paths and server names. This makes it much easier to update and manage queries across different environments. Next, I always recommend testing your queries on a sample first. Using the Keep Top Rows feature allows you to work with smaller datasets, which speeds up your testing process and helps catch issues early. When working with SQL, Enabling query folding is crucial because it pushes the heavy lifting to the database, making your queries more efficient. Creating reusable queries is another best practice. Instead of copying and pasting code, reference existing queries. This keeps your work organized and reduces errors. Don't forget to document your steps as you go. Renaming applied steps with clear, descriptive names makes your workflow transparent and easier to follow later. Setting the correct data types early on is vital because every subsequent step depends on that foundation. When you get these basics right, you're setting yourself up for analysis-ready data that's accurate, efficient, and reliable. In summary, focusing on clean, well-structured data with flexible parameters, efficient query practices, and thorough documentation will make your analysis much smoother and more effective. These are the key takeaways and best practices to keep in mind as you build your data workflows.